So here is your warm-up for today. I believe we are on May 19th right now. Okay, so you need to be finding all the places where the tangent equals the cosine from 0 to 270, and then find where the tangent equals 4 minus x squared from negative 2 pi to positive 2 pi. So hopefully you went through the process of either using your handheld or using Desmos to graph the tangent as one equation, which is my red equation, and to graph the cosine equation, which is my blue equation here. And I made sure my graph went from 0 degrees to 720 degrees. And you can see I probably go up to, I don't know, like 2 or something. It didn't really matter as long as I went a little bit past 1 and a little bit past -1. And I found all of those points of intersection. So I have 38.2, I have 142, I have 398, and I have 502. Those were all rounded to 3 significant figures. And this second one I had to change to radians and go from negative 2 pi to positive 2 pi. In my first line I put tangent of x. In my second line I put y equals 4 minus x squared. And I had to go really far down on this one. I went down to like negative 20, I think it was, to see all of those. At first I was sticking from that 1 to -1 because I had in mind the sine and the cosine, but with tangent we can go to positive infinity in the y direction and negative infinity in the y direction. So I kept going until I knew I couldn't see any more. The next point to the left of this one would have been past negative 2 pi, and the next point to the right of this one would be past positive 2 pi. So I was able to come up with 1, 2, 3, 4 answers here of negative 4.66 and positive 1.20 and 2.23, I'm sorry, 2.28 and 4.77 as my answers there. So it would actually be beneficial if you took the time to draw those graphs and make sure you can get all that information from them. Today what we're going to be working on is actually learning properties of cosine and sine graphs so that we can perform translations and stretches. Okay, so this is where it gets a little bit more difficult because we start getting into not just sine x, cosine x, but now we start adding in the period, and we start adding in the translation and the horizontal shift and the vertical shift and the horizontal stretch and all of that loveliness. So it gets a little bit more confusing when we start looking at these graphs this time. Okay, so first things first, whenever we have, and this works for cosine also, okay? So I know it's listed twice, but it's the same thing. If you are taking the function sine or cosine, and on the outside of it, you're adding a value or subtracting a value, this is going to be your vertical translation. If you're adding or subtracting something inside the parentheses with the x, that's your horizontal translation. Now these two things are exactly what we've worked with all along when we dealt with h and k. We had quadratics that had a horizontal shift and a vertical shift. We did absolute values. We did exponential graphs. So it works the same exact way. This is a vertical translation in the direction we're expecting. But this is actually a horizontal translation opposite of what we're expecting. So even though it says minus c, what we're really going to be doing is going in the positive direction c spaces. Okay, where this one we're going in the positive direction d spaces. And those same things hold true whether it's the sine curve or the cosine curve. Adding something on the outside gives a vertical translation. Adding something on the inside of the parentheses is the opposite and the horizontal translation. Okay, so you can pause it if you're writing stuff down, that's fine. I'm going to go to the next slide. All right, on this side we're expected to sketch a graph of the sine of x, and on the same set of axes we're going to sketch a graph of a, b, and c. On this one here, that's outside the parentheses, so that's going to be a vertical translation. This one here is going to be a horizontal translation, and this one's going to be a horizontal translation and a vertical translation, the two translations put together. Now, when deciding how to make my graph, I took a look at everything going on. It didn't tell me whether I should use degrees or radians until I got to this problem right here. And it used 2 pi over 3. That right there tells me that I should be using a graph involving radians. Okay, so that's what I'm going to do first is I'm just going to graph the sine of x using radians. So right now on your paper, go ahead, pause this and put a sine graph on your paper. Make it, big enough, like half of the front of your paper. All right, so there's my basic sine curve. What I'm going to do now is I decided that this one right here is actually a vertical translation of +1. So what that means is I'm going to go ahead and take every one of my points and I'm going to translate it 1 unit up. So each one of these gets translated 1 unit up. And that's not so bad to do, right? So 1 unit up, 1 unit up, 1 unit up, and 1 unit up. So this is my next graph here. I'm going to try and connect it as best I can. See, and this is why it's important that we don't make tiny little graphs. Tiny little graphs aren't going to serve our purpose very well. We need to take up as much of the paper as we can with our graph. And the next one is actually a horizontal translation. And I know it says minus 2 pi over 3, but we're actually going to add 2 pi over 3 to each one of our points. So here what we're going to do is we're going to add 2 pi over 3. 60. So 2 pi over 3 is the same. I told you before. I got to work in degrees. So 2 pi over 3, that's 120 degrees basically. So I'm adding 120 degrees to each one of my points. All right. So now to do the second one, we need to move things a positive 2 pi over 3. I didn't really necessarily look at this very well when I did my scaling. But basically what I need to do is I need to divide pi, which is actually, in my case, 16 spaces. I need to divide that by thirds. So I am actually just going to estimate this. I'm going to say that right here is about 1 pi over 3. Right here is about 2 pi over 3, and then that's 3 pi over 3. So basically that's the size that I'm going to move. I'm going to move 1, 2, 3, 4. I'm going to move it about 5 boxes as an estimate of what 2 pi over 3 is. Like I said, I should have done mine in an increment of 3 or 6 or something like that instead. So I'm going to take each one of my points and move it 2 pi over 3. So this one is going over 1 pi over 3, and then to 2 pi over 3. Okay? Which means this one is going 1 pi over 3 and then 2 pi over 3. So it looks like this one is going to about here. And the next one is going, this one here is going 1 pi over 3 and then 2 pi over 3. So once you start getting the pattern of where it's going, you can kind of estimate from there how that's going to be. So this is me moving it. This one next is 1 pi over 3 and 2 pi over 3. So right about here. And then this one's going 1 pi over 3 and then 2 pi over 3. So this looks like the next one. The biggest thing I want you to take out of this is going to go to the right 2 pi over 3. So we're adjusting the x coordinate. And this one is going up 1. Okay. So that was this point. Let me move this one. 1 pi, 2 pi. So right about here. And like I said, from that point, you can kind of pick up what's happening with the rest of the graph. And the last one, what they want us to actually pull up is this combination of the two things happening. Okay, so we've already moved up 1 and we've moved over 2 pi over 3. Now let's try and do it all at one time. So I'm going to take this. I've used red already. I've used green. Let me use this one right here. Okay, and I'm going to make this a much thicker line, actually. Okay, and what I'm going to do is go from my original spot, and I'm going to go up 1, and then I'm going to move that 2 pi over 3. So that's 1, 2 pi over 3. So there's my original point right there. This is for my third one. I'll go to my second point. I need to go up 1 and over 2 pi over 3. So it's basically that we're doing a combination of those. This point moves up 1 and over 2 pi over 3. So you can see that my final graph, what I do, I did them. So this one goes up 1 and over 2 pi over 3. So it looks like this one's coming down here. Okay. Then we'll go back and we'll go up 1 and over 1, 2. So this one's coming back down here. This one goes up 1 and 1, 2. So right to here. Like so. And this one goes up 1 and 1, 2. So up here. And like I said, once you get the pattern of what's happening, you can kind of draw the rest of it. So these graphs that we're working on in this unit is a little confusing because you're going to see a whole bunch of different colors going on. You have to know what's the start, what's the end. One of the suggestions that my prior classes has done is like when they were doing it on a test, you were supposed to be just showing the final results. So you were like just supposed to be showing this graph. So even though you're not supposed to use pencil on a test, what they would do is they would use a pencil and sketch the other ones, the steps to get there, and then use a pen to write their final result. Go back and erase the old ones. So, I mean, that's a possibility. They're only grading what's in pen. You just have to make sure you erase the old information. All right, let's see what we get next here. Here we're looking to actually write an equation based off of what we see on the graph. Okay, so right off the bat, I know that I'm dealing with a sine equation. So I'm going to start with that. So y equals sine. And the only thing we've talked about so far is translations. So there's either going to be something in here with the x coordinate if we went left or right, and then there could be something on the outside if it goes up and down. So what I want to do is I want to find a sine graph, basically. I want to find the midline of the graph that's here right now. So what I'm going to do is I'm going to take this. I want to find the horizontal midline, basically. And it looks like it's falling right here. And the way I can tell that is that my maximum point is at -1 and my minimum point is at -3. So the halfway between that -3 and the -1 is at -2. So there is my midline. All right, so keeping that in mind, it looks like my graph didn't at all move left or right. It looks like it just moved down. Okay, so I don't need to put anything in with the x. I just need to acknowledge the vertical translation down 2. So I'm just going to put a -2 out here. It's actually pretty simple to see that vertical translation. That's usually not the hard one. Sometimes the hard one is the horizontal translation, and that's what we have up next. Okay, so again, I want to always make sure I put a thought on that midline. So my highest point is 1, my lowest point is -1. So my midline is staying at the x-axis. Okay, so just because there's really nothing from the graph itself to tell you whether it's going to be a sine graph or cosine graph, because one is actually just a translation of the other, but the directions tell us that we need to write it as a cosine graph. We could actually have written it any way we wanted. If we wanted to see it as a sine graph, we can go over here, which we know sine should start there, so that would be a translation that way. Or we could go here and it would be a positive translation horizontally. But it's telling us to write it as a cosine graph. So what we need to do is, where does the cosine normally start on the y-axis? Well, it normally starts at +1. So it normally starts as that top point right there, or that top point right there. So there's actually two things that we could write here. Okay? So if this is -π/2, then this piece right here is -π/4. So we could think of this as a translation of -π/4. Or we could think of it as a translation of 1, 2, 3, 4, 5, 6, 7π/4. So we could actually write two different equations here. We could write this as y equals the cosine, and this is horizontal, so it'll go in the parentheses with the x. And we want to do the opposite of what's here. So we're going to put plus pi over 4. Or we could write that as y equals cosine, and this is a positive 7 pi over 4, so we could write that as x minus 7 pi over 4. I don't believe this one's in your book, but it's nice to recognize that you could do it either way. You could either say it's a positive translation or a negative translation. Okay? So we've seen one with just a vertical translation and one with just a horizontal translation. So now we need to write one sine equation and one cosine equation. Because like I said, it's the same equation. Okay? Now, there is other things happening on this graph right here. You'll notice that it doesn't go all the way up to 1 and it doesn't go all the way down to -1. So there is actually a stretch going on here as well. So we have to be careful with that. It does, however, something's not quite right with this. If we want to look at the cosine curve, let's go and do what we were doing before. Let's say we want to look at the cosine curve. So we know we want to go to the topmost point, and that's right there. Okay, so that would have been a horizontal translation of, so it seems weird, a horizontal translation of pi over 3. So we could say y equals the cosine, and the horizontal translation would give us x minus pi over 3. But then we also want to think about that it was shifted up. Now, this is an example out of the book, and it's telling me that it was shifted up 1/2, but I don't necessarily see that personally, because what I'm seeing is that it actually is a change. Yeah, I don't know whether it was graphed wrong or not, but in order to be shifted up 1/2, this point should actually be here. This point should actually be up at 1.5. So there's something else going on here. I think it's just a horizontal shrink. I don't think they have a correct graph with this. But what they are saying is that it should be a vertical translation of 0.5. Like I said, I don't think that's correct. That doesn't match anything that I got going on my site. Okay, let's just focus on the cosine. We're not going to even acknowledge that piece of it right now. Let's look at where the sine starts so we can see what that translation would have been. Well, the sine normally starts, I got to find that midpoint. It's really hard to find that midpoint right here because of everything that's not quite right with this. But let's just say that the midline is the x-axis. We can say that the sine would have normally started here. So maybe that's negative pi over 4. They've got it as positive pi over 6. Oh, they're all sorts of weird. But anyway, I want to look for the midline point. So if we're calling the x-axis our midline, I'm going to say that that's about negative pi over 4. So x plus pi over 4 would be that translation there. This is not a very good example. I think this is from the book you have. I wonder whether the new book actually has fixed this problem or not. I'll have to check into that. Let's look at the next question, or the next problem here. So that has to do with your translations, up and down, and then side to side. But then we can also deal with our stretches and our shrinks, basically. Okay, and that happens when we do multiplication. So basically, the easiest one to look at is the vertical stretch. A vertical stretch happens and changes the amplitude. It's the constant that ends up being in front of the sine or the cosine. So normally we don't write anything there. It's automatically a 1. So automatically we're used to the amplitude being 1. Okay, so the amplitude is going to now be, or the stretch is now going to be what's in front of sine or cosine. And because it happens vertically, it is what we expect. If it is 2, that means that it's going to be twice as big. If it's 1/2, it's going to shrink it and make it smaller. Okay, all right, so let's see that happen here. So let's go ahead and I'm going to sketch the cosine graph. We'll do that really quick. You can pause here and draw one for yourself. All right, so there's my starting cosine graph. So what's going to happen is right now the distance between the midline, which happens to be my x-axis here, and the highest point is 1, and the distance between the midline and the lowest point is 1. And that's because the amplitude, or this value in front of cosine, is 1. Now I've changed it to 1/4. Okay? So basically, for this graph right here, for letter A, and I just circle it with the right color that I'm using just so you can reference that instead of labeling it on the graph, that basically everything is going to go to 1/4 of what it was. All right, no big deal, I can do that. So instead of going up to 1, I'm going 1/4 of that. Instead of going to -1, I'm going 1/4 of that. At 0, I'm going to stay at 0. Instead of going up to 4, I'm going to go to 1/4 of that. So I have basically like this little shallow cosine graph happening here in red, because we shrunk it to 1/4 of what it originally was. So here, and then here, and here, and then 1/4 there. Okay, so that's what 1/4 in front of the cosine would do to it. Okay. Now the second one there is saying a -2. Now, this actually is two things that's happening here. It's making the amplitude double its size, but then it's also flipping it over the x-axis. So instead of this point being at 1, we move it to 2, but then flip it down to here. This point being at 0 stays at 0 because we multiplied by 2 and it's still 0, and we flip it and it's still the same. This point down here was at -1, so when we multiply that by 2, we get down to -2, but then we do the opposite sign, so it actually moves it up here to +2. So you can see this is what this graph is going to do to us. Like that, and it's still going to go through the same zeros. If all we're doing is changing the amplitude, because the y coordinate on the x-intercepts is 0, it doesn't change that. So this one comes down here, and it will be at -2, like that. It just becomes difficult when you try and put all of this stuff together, that's all. When you try and have all of the major things happening at the same time. And I will tell you, we don't necessarily usually have to graph all of them happening at the same time. Okay, usually what's happening is we're just looking at and pulling information out of the equation themselves. Okay, not actually trying to redraw. All right, so there is the vertical stretch on those graphs. So if you need a couple seconds to draw those, go ahead and pause it. I'm going on to the next thing. All right, so the last one, which I actually think is the hardest one, is the horizontal stretch. Okay, and that's because this actually affects your period. Okay, the period of your function. Because what we're now doing is, instead of saying that we started at 0 and 1 revolution or 1 period, 1 repetition goes at 360 or 2 pi, we're either making that smaller or making it larger. This is the absolute last thing that I usually do when I'm having to draw something. Okay, now just like what was in those parentheses for the horizontal shift, we acknowledged the opposite. So if it said minus pi over 2, we actually went in the positive direction. And if it said plus, we actually went in the negative direction. Kind of is opposite, if you will, with this also, in that we're going to multiply by 1 over b. So if this b value inside with x is 2, it's actually going to be a shrink to 1/2. If that b value that's in there with x is a positive 5, it's going to be a shrink to a 1/5. If it's 1/4, it's actually going to multiply it and stretch it out on the x-axis by 4. Now, one of the biggest things that you need to remember, and this is not one of the things in your formula packet, is how to come up with the b value in the equation. Because our original period of the original cosine, sine, and tangent graphs is 2 pi, our period is now going to be calculated by doing 2 pi divided by the absolute value of b, of whatever that number is in there. Okay. If it's in degrees, it originally was 360, but now it's going to be 360 divided by the absolute value of b. There's a lot of times that there'll be a question that says, okay, here's this equation. What's the period of the function? In order to get that, you have to take 2 pi and divide by whatever number is in that equation. Okay. So it's not just, everything else is just kind of there in the equation for you and can jump out at you. You actually have to do a little bit of figuring to figure out the period. All right. So this is what I was just talking about. But for tangent, because tangent's original period was not 360, was not 2 pi, this is the, I don't even use this very much. I don't think I've ever used it. But this is the tangent one because the original period was 180. Okay, the original period was pi. Most of the time we're dealing with sine and cosine, so this isn't as crucial. All right, so let's go and see what happens here. This is your closure for today. So what I want you to do on your closure is I want you to catch 3 different graphs, basically. A sine, a tangent, and a cosine. Okay, and I want you to see if you can draw the original sine graph, and then what would happen if horizontally we changed the b value to 0.5. And then the tangent, what would happen if we changed the b value to 2? And for C, what would happen if we changed the b value to 3 and also did a vertical stretch of 2? Okay, so you should be able to get 3 graphs out of that. All right, so that's your closure assignment for today. I'll talk to you next class.